University. It's an awesome class. And happy Veterans Day to any and all veterans, past, present, and future. So today we're going to go ahead and kick off oxy-fuel cutting. We're going to say oxy-fuel cutting. We're going to be using oxyacetylene for this purpose. So you can also use polypropylene, MAP gas, propane, but for this demonstration we're going to go ahead and use acetylene. Acetylene is a great fuel source. Acetylene is a great fuel source because it is the highest heat. So we get about 5,500 degrees Fahrenheit when we use acetylene. So faster cuts. We're going to go through the basics. We're going to start up the setup. Sam Hackman over here, he's going to kind of walk you through testing. He's going to go through step by step everything that we talked about. He's going to go ahead and demonstrate. We're going to set it up, check for leaks, select the appropriate tip for what we're going to be cutting on. He's going to do a couple cuts, and then we're going to go through the breakdown procedure. All right. So the first thing we're going to do is we're going to start off with our oxygen tank. You can start off with oxygen or acetylene, it doesn't matter. We're just going to go through, we're going to hook up the regulator. So you'll notice, got a cap on there. So anytime that I set this up, I typically take a wire brush and I clean up the external threads. We don't have that, but we'll be good. Everything's pretty new. You want to make sure everything is clean and serviceable. So if you have any cracks or dings on the lenses of your regulators, you want to go ahead and get that swapped out or get it put into service. Now if you have a T-handle regulator, which isn't what we have here, but if you have one of the old school T-handles, you want to make sure that you point that up and out of the way. Okay, if there's anything wrong with that regulator and you back that T-handle off, it could become a projectile. Okay, he's going to go ahead and set up the oxygen and then the acetylene as well. Sometimes the caps get stuck on there. If they do, don't put anything in the hole on the side and kind of crank it out. You can give it a couple taps with a crescent wrench or a small hammer on the outside, and that'll kind of free up some of that oxide that's built up on there and allow you to unscrew it. Another thing, you don't want to put any petroleum products on there. So you don't want to put WD-40 on there. You don't want to put all right. Anybody from ESAB or Victor in the audience available? We need to get an acetylene regulator. Anybody? Left us out here to dry. Okay. So Sam's going to go ahead and finish setting up the oxygen while we track down the appropriate acetylene regulator. So you'll notice that the bottle is green, you know, depending on which company you get it from. Don't trust the color. You always want to check the sticker or the label that's on the exterior of the bottle. Okay, because a lot of companies now they're painting theirs completely blue or purple, depending on which company they're going with. So don't trust the color of the bottle. Always verify the label of the contents that's inside of it. So you'll notice that the green line is our oxygen line. So everything that we set up is going to be right-handed threads. Okay, all of our oxygen connections are going to be right-handed threads, whereas regardless of the fuel source, they're all going to be left-handed threads. And you'll notice, do you have that? This one doesn't have it either. Gosh. No. So you'll notice on all the nuts for the fuel source, they're going to have a little V shape in there, a little groove. That's going to tell you these are all left-handed threads. That's to prevent welders from hooking things up backwards. Okay, you can't screw this up. I say you can't, but somebody will make a liar out of me. So he's going to go ahead and set that up. Same thing, we're going to go ahead and hook up the torch. Now this is a combination torch, meaning we can disconnect that head and we can put different heads on there. So if we're going to do oxy-fuel cutting, if we're going to do a little bit of brazing, or if we're going to use a Rosebud, you can actually swap those heads out. Now with a standard cutting torch, you don't have that liberty. Here we go, we got the right. Thank you, ma'am. So Sam's going to go ahead and hook up the acetylene side. Like I said, it doesn't matter which one you hook up first. And then we're going to go through and we're going to secure all of our connections. Okay, one thing you definitely want to check is you want to make sure that you don't have any leaks. Okay, especially in a welding environment, there's a lot of sparks and things going on. This hose here, at about 25 foot of that hose, is the equivalent to a quarter stick of dynamite. Okay, once it's fully pressurized with oxygen and acetylene, it's the equivalent of a quarter stick of dynamite. So you don't want that laying around your feet with leaks in there. So you're always going to go through it. Once you pressurize the system, one thing that I typically do, I don't have spray bottles of soapy water with me. Contesco makes a good product that you can do leak check with, and you'll be able to see the physical bubbles that are coming out. Anywhere that there's a leak, you don't have a tight connection. So one thing you can do is pressurize the system completely and then turn that valve off on the bottle. If either one of the needles drop, you're going to know that there's a leak, and then you go through and check all of your connections. Same thing with the acetylene. You're going to do the exact same thing with the acetylene. You want to make sure that you don't have any leaks in the system. Now when we start getting into cutting, we want to make sure that we have the appropriate protective equipment. So as you can see, Sam has a welding jacket on, he's wearing non-flammable pants, and he has work boots on. You don't want to wear synthetic fibers. Synthetic fibers, anytime you get sparks or molten metal on them, what they're going to do is they're going to melt, and they're going to melt directly to your skin. So you don't want to have polyesters or anything like that, any synthetic fibers. You want wool, cotton, denim, any of those fabrics are going to be the appropriate choice for safety. Okay. In addition, safety glasses, welding cap, earplugs are another good thing to have. Anybody ever have a hot spark in their ear? That hurts, don't it? That does not feel pleasant. So in addition to that, we're going to make sure that we wear gloves. You want leather gloves. You don't want to wear like mechanics gloves. I'm guilty of wearing mechanics gloves, you know, before I knew better, but they're all synthetic fibers. You don't want those on your hands, right? We work with our hands every day. The last thing we want to do is tear them up while we're working, right? That's how we make our living. So in addition to that, you want to make sure Sam's going to go ahead and use his new ESAB welding hood. So it does have a grind mode in there. You can use grind mode or cut mode. Okay, so this one does have a cut mode. So I recommend typically a shade 5 to 6 when you're doing oxy cutting operations. I like to have a full face for obvious reasons, right? You don't want to burn up the beard, right? You can relate, right? Okay, so you don't want to burn up your beard, so I like to cover up my face. You can use tinted safety glasses and a clear face shield, or you can use clear safety glasses and a tinted face shield, or you can use the welding hood. If you have a digital welding hood or an auto dark welding hood, a lot of those have those functions. Take advantage of that, okay? Good?
Yeah.
All right, you already checked for leaks? Okay, so one thing to note is the oxygen cylinder is a high pressure cylinder, meaning you have to open that valve all the way up for it to work properly. With the acetylene, we're only going to do 1 to 1.5 turns, okay, full revolutions. And that's simply because if for some reason there is a fire, okay, we can go over there with a glove and we can shut that off relatively quick. You also want to check your working environment that you're going to be working in. Okay, these sparks can travel, the sparks of molten metal can travel up to 25 feet. So you want to make sure that oily, greasy rags, co-workers, cardboard, paper from packing material, you want to make sure that's all out of the area. Any type of solvents, anybody work with acetone quite frequently? It's in a lot of welding shops for cleanup. Make sure all that stuff is out of the area. Make sure other trades in the area that you're working in, they know and understand that you're going to be doing cutting operations. I've actually had people that, you know, painters come in while I'm doing hot work and set open buckets of acetone underneath where the welders are working. It is not a pleasant experience, okay? Especially when the guy on Firewatch is playing on his cell phone. I don't know where to stand. All right, you all set up?
Yeah.
Okay, so Sam's already set up, so before we get into it, okay, Victor has these nice little charts. Okay, there's one for acetylene, there's probably one for MAP gas, propane, polypropylene, any of those sorts. So depending on the thickness of the material you're going to be working with, you want to reference this card. Okay, because if Sam tries to make cut up some 1/8 inch material with a number 1 tip, it's not going to work out so well for him, especially if we're looking for quality of cut, right? We want to try to minimize the amount of work. We don't want to make extra work for ourselves. So what are you going to start off with, Sam?
I have number 1 tip, so I'm going to run at 5 and 50.
Okay, so Sam has a number 1 tip. He's going to run it at 5 acetylene and 50 oxygen. Okay, and that's PSI. You ready? Yeah. All right, so Sam's going to go ahead and demonstrate a cut. I think he has some 1 inch thick plate up here. You guys should be able to see everything on the screen. I'm going to turn the mic off and step out of the way so you can go ahead and make this cut.
How to set your acetylene.
Okay, you want to go, okay. Okay, so the first thing we're going to kind of hold it up. They should be able to look at that. All right, so he's going to go ahead and he's going to set his flame. So he's going to crack the acetylene very slowly and then ignite that. Okay, and then you want to wait for all that soot to come down. So he's going to adjust his acetylene. He's going to open it until all that black soot comes out and you have a nice bushy flame on the end of it. Once that's obtained, he's going to open the oxygen all the way on the bottom of the handle. Just open that all the way. And then you'll be able to regulate your cutting oxygen at the top. So he's going to make what's called a neutral flame, okay? So you'll notice all the cones come down to a nice even level. Everything's in line with each other. If you have any longer, that's not good. So if you have too much acetylene, okay, in your mix, that's known as a carburizing flame. So think of a carburetor, fuel, right? That means I have too much fuel in there. It's running really rich. And what that's going to do is it's going to develop carbon deposits in your welding area. Now you have hard brittle zones in the area that you're going to be attempting to weld. Okay, you don't want hard brittle areas in your welding area. Same thing if I have too much oxygen in there, I'm going to have oxidizing flame, and you're going to end up with porosity, you're going to end up with a lot of other crap in there. You don't want to deal with that. Again, it's going to create hard brittle areas in your welding zone. Okay, ready? So he's going to go ahead and heat up the piece. You're going to notice it's going to turn to a nice bright glowing, it's going to have a nice bright glowing look to it. That is known as the kindling temperature. Okay, he's getting it brought up to temp to where he can cut with it. Now with this, the oxygen actually does all of the cutting. Okay, everything else is just to preheat it. The oxygen is what's doing the cutting. With oxyacetylene, it's actually a chemical reaction that's happening right here. This is an accelerated rusting process, okay, or an accelerated oxidizing process. So it's very similar to rusting the metal apart in a very precise manner. Okay, so he's got a nice clean cut there. Okay, now notice when he shuts the torch down, he shuts his oxygen off first and then his acetylene off second. And I know there's a big controversy, there's a big debate about that. When you shut off your oxygen first, okay, you do that for a couple of reasons. Once you turn that oxygen off, you take away one of the parts of the fire triangle, which is heat, fuel, and oxygen. Okay, you take that oxygen away, you still have fuel, you still have oxygen in the surrounding area, but once you start to turn that acetylene off, if you have a leak in your system that you didn't detect prior, maybe the seat on the back of your tip, okay, has a little ding in it that you didn't notice before. Anybody ever go to shut their torch off and they still have a small flame going at the end of it? You have a leak in your system. Now if you shut off the acetylene first, you wouldn't have caught that. Okay, also if you shut off the acetylene first, you're going to develop a loud pop. Anybody ever experienced that? This man right here. Okay, so what's actually happening is you're pulling carbon deposits to the inside of your tip. Okay, now when you do that, you're clogging up that tip. Okay, it's actually pulling, it creates a vacuum. Does anybody have a dime? 10 cents US? And then this Canadian stuff. I know we're close to the border. It actually creates a vacuum at the end of your tip. Okay, so we have a regular dime. I'm not a magician. But if I put this up here, you guys would tell. Is that creating a vacuum? Is that sucking or is it blowing? Anybody? Okay. So it's blowing. Everybody agrees it's blowing, right? Oh, shit. Anybody have another dime? And now for my next trick.
I got another dime, brother. There's one.
There we go. All right, last chance. So you can actually pick up a 10-cent piece. Okay, it's actually creating a vacuum when you cut with this. So if you get your, what they call the coupling distance, where your flames, the little blue flames are off that material, if you get that too close and you start cutting, what do you think is happening to the tip? It's pulling up impurities inside your tip. Next thing you know, you make a nice, clean, beautiful cut, but you're dragging the tip too close, and now the thing is popping and sputtering. You're like, man, this thing's a piece of crap. You know, this is the stuff that my employer gives me to work with. You're too close to the material. Back off a little bit, okay? Another thing, when you clean your tip out, a lot of people don't take the tip out of the torch. They just clean it. They put the needles right inside of the tip while it's still connected to the torch. Well, what happens when I pressurize that system? All that crap's going to go blow back up in the tip and it's going to get wedged up in there again. So it's very ineffective. Okay, do you have anything you want to touch on?
No, that was good. I was going to say I always use the long torch tip cleaners because I always prefer the long torch tip cleaners. So when you take your tip out, you can clean it from the back and push everything out through the front. That way you're not getting anything stuck in the tip.
So I mean, you want to keep everything clean and serviceable. I highly recommend use the right tip for the nozzle that you have. Don't use the drill bit type and over drill that and try to open those holes, because these things are a specific diameter and a specific length so you can get the correct cut. If you start opening those orifices up to allow stuff to fly out of it, it's not going to cut worth a crap. You want to cut some thinner material? So when we cut thick material, we want to cut at a 90-degree angle. But if we start going into thinner material, and by thinner I mean like 1/4 inch or less, you're going to have a little bit of a leading angle on there. So you're going to push that cut along the path. Another thing you want to think of is like we talked earlier. Okay, so we're going to go ahead, we're going to switch the tip out. So we're going to go reference back to this chart and find out the appropriate oxygen and acetylene pressure. So we'll switch back over. He's going to switch his tip out for something more apt to cut 3/16 material. So probably a double aught or a triple aught tip.
We got a double.
Okay, and then we're probably going to drop to about 3 to 5 for our acetylene and 20 to 25 on our oxygen. Okay, and then he'll cut at a push angle. So when you put this stuff together, you want to make sure that you don't crank down on it. You don't need to put a lot of force behind there. You don't need to put like a cheater pipe on there and crank this stuff down. It's brass fittings. It's very soft. It will strip easy if you don't have the appropriate size wrench. In addition to that, you don't want to mess up the threads. This stuff's highly expensive, you know, to get it redone and repaired. And that also puts you out of work, right? Because now you're waiting on your tools to get repaired. I mean, unless you have a bunch of torches laying around, take care of the stuff that you have. Don't over tighten the fittings, because you'll just tear the threads up. Like I said, it's very soft material. You don't have the tear. I was looking for the tear weight on there. Huh? No, it should. So I was just looking for the tear weight on the acetylene. What that is usually when you get an acetylene bottle, you guys ever seen numbers written on there with a paint marker? You know, say like tear 205. Okay, that's the weight. So acetylene isn't done by PSI. So when they fill those up, they actually fill it up by weight. So anybody ever had a propane tank filled up before? Okay, they usually put it on a scale and then they'll fill it up and then you pay by the weight. Acetylene is very similar. It's filled with calcium carbide, and on the inside of that is it's got like a porous membrane in there. And what that does is they pour acetone, liquid acetone in there to stabilize it. Acetylene is can be a very volatile gas, so you don't want to withdraw it. You don't want to run it at 15 psi or higher for any application, but any other application, you don't want to withdraw the contents of that tank 1/10 of an hour. Okay, so whatever the tear weight is, let's say it's 200, you don't want to pull out any more than 20 cubic feet per hour. Okay, so how do you know? How do you know how much you're pulling out? Okay, especially if you switch over to a Rosebud application. Anyone ever seen one of these? Use one of these? Light it up, you can't keep it lit because it keeps popping. Some of you are smiling because you know you're guilty. I won't tell on you, right? So what's happening is you're starving that torch for fuel. It cannot pull enough of that fuel gas up. So what it's going to try to do is it's going to start trying to pull liquid acetone from the cylinder. You're going to notice you're going to get a nice purple flame out here. This thing's going to pop. It's going to start smoking. It's going to start screaming, and it's going to start getting cherry red. Okay, that's because you're starving it. What you actually need to do is drop down to a smaller Rosebud, or you need to get a bigger tank, or you need to use a couple of tanks on a manifold system. Okay, if this thing's like fighting you, don't force it. Okay, you're going to end up, hurting yourself. You all set up? All right, Sam's going to go ahead and make a cut on some 3/16 material. What size tips you put in there?
00.
Okay, so he's got a double aught tip. He's going to go ahead and do a demonstration on how to cut. Again, he's going to go ahead and light his acetylene first, get rid of all that black soot. He's got a nice bushy tail on there, and then he's going to drop down to a neutral flame by increasing his oxygen. Usually what I like to do is hit that lever and just verify that all those cones are symmetrical still. Okay, if those cones are one sticking out longer than the other, that tells me I need to clean my tip. So notice he's going to have a little bit of a push angle. Anybody ever weld the material back together they're trying to cut? It's because you're going too slow or you don't have the steep enough angle on there, so it's actually going to start solidifying behind you as you cut. But not Sam, look at him go. All right, so the information I was referring to on your Rosebud if you look on these charts right here, it will actually tell you. That's why these charts are so important, okay? And they usually come with all the kits that you get from Victor. If you look at it, for the heating nozzles, over here on the table, we have a number 4 heating nozzle. The acetylene pressure is 6 to 10, and the oxygen is 8 to 12. And it tells me right here, if I run 6 to 8 on the oxygen, I'm going to burn 6 cubic feet per hour, okay? Now, if that acetylene tank that I'm working with, if it can be withdrawn to like 10 pounds per hour, I'm safe to use that. But once it starts getting out of that area, that tells me I need to get a bigger tip, or I'm sorry, I need to get a bigger tank, or use a manifold system, or I need to drop down to a smaller preheating torch. Okay? You got anything you want to cover?
No, with the acetone point in the bottle that you can't use acetylene on its side. You can use an oxygen on its side, but not an acetylene on its side.
That's a good point. So because of the liquid acetone that's in that acetylene cylinder, that's one thing I forgot to mention. If it's left on its side, like you throw it in the back of the car like you're not supposed to and you drive it back to the garage, stand it up for 1 to 2 hours prior to use, because now you have that liquid acetone in there that's going to try and get out of the bottle, and it's going to go through, it's going to gum up your regulators, gum up check valves, flashback arrestors. So you'll notice, borrow that real quick, at the bottom of this, with these new torches, they have the flashback arrestors built into them. Okay, they're already in the torch. Flashback arrestor is going to prevent any sparks or live flame from going back into the system. A check valve will only allow gas to flow one way. So most of the new torches have all that technology built into them. If you have an older style torch, you can get separate check valves, flashback arrestors. I highly recommend, especially anybody here in education. Okay, so if you're in education, the coolest thing I found is a resettable flashback arrestor. Okay, so that means it's not just one use and it's done. Okay, if it's ever tripped, you just go over to the side, you give it a quick pull, it turns green again, and you're good to go. They're expensive initially up front, but after that, I mean, the first time you got to reset it, it pays for itself. Okay, and then your students can't tear everything up. I mean, they can, just not that particular part, right? So actually, when I worked in education, I worked same facility for about 4 years, and we still same check valve, same flashback arrestor, just because they can't tear them up, because you can just go over there and reset them. That also tells the student, hey, I screwed something up. Okay, so then they go back through the system, work through the system, and find out where they made the mistake. Okay. Again, with the acetylene, make sure to stand it up for 1 to 2 hours, because of that porous membrane that's in there, it's gonna take a while for that liquid to actually settle back down to where you can operate it effectively. You got anything else you want to cover? You're good. Okay. Any questions up to this point? No? Okay, we'll go ahead with the shutdown procedure. Like I said before, you're going to shut your oxygen off first, then the acetylene, and then what I do after that typically is I'll shut down both my bottles, the acetylene, the oxygen. At that point, it doesn't matter which you shut down first, but then you're going to go ahead and bleed those lines back out, because I don't want fuel gas inside those lines. Now, once he shuts those off, he can, depending on how long you're going to leave this system set up for, if you're going to leave it overnight, you can leave the regulators, everything attached. You can leave the material side by side, but I think after 48 hours, OSHA mandates that you separate these two, and you have to check with your local building codes. But usually cinder blocks are 3/8 plate, and they have to be separated from one another at 20 feet or better. So overnight is fine, but over the weekend you want to separate these things, break the entire system back down, cap everything off just for safety, and then you should be fine. Always make sure when handling the cylinders that if the regulators are on there, that they're attached to approved cart. Okay, so like this, or in a cage, or fixed to a wall unit, or they have standalone units or roller units like we use on weld.com in our shop. Make sure those things are secured. Okay, you don't want these bottles to tip over. Everything up top from the neck up is all brass. Okay, so it will shear. If that thing tips over, it can actually, I don't know if you guys have ever seen the episode on Mythbusters where it goes through a brick wall. Okay, you don't want that to happen. Okay, so make sure the cap is in place. If your regulators are not on the system, make sure you have the cap in place. You can buy the little halos that go around there that kind of keep it, protected so nothing else swings into it. Anybody work around cranes? Crane ball, take the top of that regulator off like that. Okay, so make sure you keep the caps on there or use a halo for, I highly recommend using one of the halos if you're doing work outside in the field environment, because you never know what can happen. So you're going to go ahead and break everything down. So he'll bleed the system out, make sure all the oxygen's out, all the acetylene's out. Remember, all your fuel connections are left-handed threads, so you have to go completely backwards. It still messes with my head. As many times as I've put the system together, taking it back apart, I always try to work it the opposite way. It's not going to work for you. Another thing that's built into the acetylene here, you'll notice on top, there's a little nut that's sticking up in front of that valve. Okay, that's a burst disc. What that does, it melts at about 220 degrees Fahrenheit. So if you do have a fire up there, those little plugs will melt and it'll allow the system to off gas. Okay, that way it doesn't turn into a big old stick of dynamite. It'll allow that stuff to burn off completely without having to worry about explosion. So I actually had an encounter with that. I had a coworker that was working behind me and he was cutting above and didn't check the system for leaks. I was on the first floor, grinding, working, being a good apprentice like I'm supposed to be. And I turned around, there's just flames shooting off this thing like 3 foot. And I'm freaking out, and I'm yelling at everybody, and we all do the same thing. We're all run outside. So we're standing outside, waiting for this thing to pop off. Luckily, it never did. So our foreman actually walked in with a glove, and gave it 1.5 turns and shut the whole system down, and it calmed itself down. We checked it for leaks. Replaced the regulator and the duplex hose because that was completely fried, and then we went back to work and we felt kind of tiny. So they won't explode. They shouldn't explode under normal working conditions because those little plugs that are in there, they'll melt off, so you don't have to worry about that. Sam and I both recommend using the appropriate size wrench. I don't have he's got an adjustable wrench over there. Neither he nor I like working with those. But sometimes that's all you have at your disposal. One thing I highly recommend, there's usually a wrench that comes with this stuff. As soon as you get it, go ahead and throw that in the scrap bin, turn it into a piece of artwork, because they're junk. Just get you an 11/16 wrench, and then usually 1 1/8" for your regulator, or 1 1/16", depending on who designs the regulator. And just have those on the cart. Put a chain on them. You work in school, put a chain on it. That thing will grow legs and it'll walk away, and nobody's seen anything. The man in the woods came in and took the wrenches. I've had several instructors contact me. We actually did a full-length oxy-acetylene video that's available on YouTube if you guys want to use that, as well as welding symbols 1, 2, and 3. So if you're kind of iffy on welding symbols, you can go check those out. Great episodes. Does anybody else have any other questions for myself or for Sam? No? All right, well, thank you guys for coming out. We definitely appreciate it. Thank you for supporting ESAB. They make some great products. Check out their full new line. They've got brand new Sentinel welding hoods available, so check those out. I'm definitely going to be sniffing around one of those. If you haven't looked through an ESAB Sentinel yet, amazing. They have a great field of view in there, so check those out. We also have classes, additional classes this week. Mike? Yeah. Okay, so we have a TIG Basics class. Oh, no, I'm sorry. I can't read. Oh, that's the daily schedule. I'm sorry. So there's actually additional classes throughout the week. I know, I think Bob Moffat's going to be here tomorrow doing a class on the basics of MIG, as well as an advanced process going through modes of metal transfer, so spray, short circuit, globular. And then on Wednesday, myself and Andrew are going to be up here doing a stick welding basics, and then D11 that afternoon. So if you're having problems taking a 3G or 4G weld test at school or your employer, we're going to be running that with some 7018. So we definitely appreciate you guys coming out. Thank you.